So this is showing you how the isobar goes down as the frequency goes up. And what I've got here on the fine lines are materials with 42% resin. Resin has an isobar much less than the glass. So the more resin you have, the lower the isobar is going to be. The other thing is, if you want low-cost laminate, you don't want to use a lot of resin. It's more expensive than glass. So all the so-called consumer materials that go into simple products have about 42% resin, and that's all these thin curves. And you can see this stuff you call FR4, which is really some kind of epoxy blend, starts out about 4.9 and is going down. If I go to 55% resin, which is the kind we're going to have for thin laminates, look how fast it came down. And it's headed, it looks like, for 4. The question is, does it keep going down? And the answer is no. So this is measuring 4 different materials, where GTAC is the stuff that you now call Megtron 4. And you can see they all do the same thing. They all go down. And you notice that if I start with a 1 megahertz value and I am operating out here, I'll start out with a big error. And that's the most common error that fab shops make, the 1 megahertz value. Well, the good news is the edge rates you and I are working with now all have frequencies above 2 gigahertz. So look at that, that's pretty flat. This is another test of my fab shop. What frequency are you using for isobar? They better say something around 2 gigahertz or higher. Otherwise, we're going to have an error just because they've got the wrong isobar.